My name's Dean Anderson, product manager for Sirovision. Part of my role is quite exciting and involves a lot of R&D, and one part of the R&D involves flying drones around. So it's quite a fun topic to talk about. This is the first of 3 presentations that we'll be doing over the next few hours. So I just lost control for a second there. My one will just be about the taking of the photos, some of the different techniques that have been used over the last 20 years, as well as just different things that we can do with them and why we do them. The second presentation will be based out of Lithuania, which will be with the close partners of ours, PixPro, and they'll sort of go through the modeling process and the different sort of things that you can do with images and some of the exports that we can have that then we can work with in Sirovision, which will be our third presentation, which will be from our Lima office, and they'll talk about how some of the remote sites in the Andes send them data that they work on, do some geotechnical analyses, and then they'll send that data back to the clients. So first of all, why do we use drones at all? Well, apart from being a lot of fun on the weekends, they also improve safety. They can remove the need for a geologist to get up close and personal with some of the pit walls. They can also remove the interactions between geologists and any sort of mobile equipment, especially if you've got some kind of a lookout on the edge of a pit or a certain area that you're always doing your drone flying from. You know where they are, and they can get all their images in that way. The other thing is the image quality that a drone can give you now from areas that would otherwise be inaccessible is better and better as the technology gets. In 2014, I think it was when the first sort of drones came out into the market that you could, that came with inbuilt cameras and that sort of thing. I remember we were flying them around and we're just taking still shots of the pit. In the last 6 years, we can now take very, very high resolution images and stitch them together and build models, as I'll show you in the next few slides. So the evolution, and these dates aren't exact. It's just nice numbers, 2000, 2010, 2020. Around 2000, before we sort of really used photogrammetry and drones and that sort of thing, we used spray paint and we used normal DSLRs, and we'd take a photo of the wall and draw pretty pictures and put in presentations and that sort of thing. It looked good, it served a purpose, but in terms of exporting georeference strings and everything, we'd still go back to digitizing and all the rest of it. In 2010, software such as Sirovision would use stereo pairs to build small 3D models. They were very good. They allowed you to map on a computer screen, dip directions, strike dip, and you could begin, and the geotechnical tools that came with that just kept getting better and better. Today, we now use drones to fly and take large-scale 3D models of entire pit walls, entire pits. It's very quick, very easy. You can fly a large area in as little as 5-10 minutes. And I think it was a month ago, 2 months ago, we flew an entire 1 kilometer face in about 25 minutes. I think that's it's about 40 meters high over 1 kilometer, and stitched that together within a couple hours. So it's very, very fast these days. So in a sense, a bunch of images that you've taken of a similar sort of area. You can, and it doesn't have to be with drones either. You can use your mobile phones, even DSLRs, anything. You put them into the software, and we'd stitch all the photos together. You can sort of see down here in the right-hand image, each one of those blue rectangles aimed towards the wall is an actual photo that's taken. And when I flew that, I just set it to automatic. Every 2 seconds, take another photo and just fly slowly across the wall. It's really made it a lot easier as drone technology has advanced. So we started with vertical drone imagery, I think a few years ago now, and this was the first sort of softwares that would stitch together photos to build 3D models. Were all vertical photos. You could have flight planners. It had formed basically a grid, and it was great for surveying. You could take volumes from stockpiles. You could do very short-term reconciliations almost day to day on areas that were mined out. You could see 3D models of where your ramps were. It was much easier to see things, but the geology, it wasn't so useful for wall mapping. You can sort of see down here these lines on the bottom image that was sort of a dotted line across. It was you can't tell whether that's a vein or some kind of fracture or something like that. So just while we're waiting for that, this is actually a local quarry. So it's an inactive pit that they're using. The pit next to it, a few hundred meters away, is quite big, but this is the area that they let me into to film last weekend. As you can see, that's the vertical down image. It's actually a 3D image. As soon as the video can sort of rotate a little bit for us and show. Yep. Okay, so that's actually a 3D model that's about to be rotated. And you sort of see it's a very good image, great for in plan view, but as soon as you sort of turn to the side, we sort of miss all definition of the pit walls. Even if it's a tiny quarry, it sort of highlights the point I'm trying to make on this one. So for the last couple of years, we've sort of been working on ways to do this better. We can sort of see it's still not clear in there what that vein or fracture actually is. Well, there we go. See, so it's a great looking image from the top. Surveyors love it, engineers love it, but geologists are a little bit frustrated when it comes to trying to map on something like that. So oblique drone imagery is where we turn the angle of the camera towards the pit face, towards the pit face, the pit walls. And you can sort of see here in this view, the camera has sort of been tilted towards the face a little bit. And this is just flown manually, so there's a little bit of overlap in things, but definitely not vertical looking straight down. And we're focusing on the walls here. And see this bottom image, definitely fractures, not veining. This is just a basic granite face, obviously. Highlights in there. Ideal for structural mapping, lithology, all the rest of it. Not sure what anyone would be getting out of in terms of lithology mapping in this one, but for structural, definitely. I'll show the second video, exactly the same area, but filmed with a slightly different angle. You can just sort of see straight away it comes out. Now what we do with this model now is we'd export that into Sirovision and we'd map on planes such as this one here, get the angle, we'd work out the direction of some of the fractures. Do they daylight? Do they form wedges? All that sort of analysis we do. And you can sort of see the detail in that granite as well. That's stitched together photos. So it's not a single photo. We're at 5 or 6 photos for this area on screen at the moment. There's an old drill rod there in the right. The odd little vug down there. You can tell I'm a geologist. It's come a long way. Now in the third presentation we do actually show a pit with multiple benches on a much bigger scale. This is just a bit of an introduction into it. Let's see some old drill holes in there. So vertical versus oblique imagery, so the last couple of years. So it gives you the ability to map onto the face, takes away any unnecessary exposure to high walls or mobile equipment for a geologist. One of the advantages as well that ground control points in one of our more traditional methods of just taking photos of the face with DSLR cameras, we can now put them on the crest and on the pit floors and use a combination of oblique and vertical imagery to get those ground control points in, so we can georeference it down to a couple centimeters or less. And you can see in this bottom image, which is just a screenshot of Sirovision, of some of the mapping that we've done, and that was done just in less than a minute. I just quickly ran across it, across the model that we've done in there that you saw in the video previously. So it's very quick, very easy, and it's really opening up areas that we wouldn't have otherwise been able to map. So that was just part one of it. In part two, we'll be going across to Lithuania, where we're building the models and showing fully what we can do with photogrammetry and drones as the technology gets better and better. That's probably in about 7 hours' time if anybody's awake. For the meantime, are there any questions that I can answer now?
Yes, absolutely. We have a couple of questions in from Kirsty Marshall. Kirsty asks, would it take more or less time to collect this data with drones compared to in person? And the second part of the question is, how many photos would you normally take?
So generally when we take photos, if you're looking, I'll answer part two first. if you're looking at a pit face, you're looking about an 80% overlap between images. Now, if you're 10 meters away from the face with the lens, that's quite a few photos. Just depends on that range. If you're further away, it's less photos. So probably about 40 photos to if you're 20 meters away over 200 meters. That's an estimate off the top of my head. But as that thing's taking photos very rapidly, it's still looking at only a few minutes to cover an entire face that way. So it's very quick. For part one, in terms of the old method, we used to line up for the stereo pair images, you'd take 2 photos of the same part of the face. It'd take you a few minutes for each photo. So the time differences are very obvious. So you're probably taking an hour or 2 to get the photos of a 200-meter face, or maybe an hour for a 200-meter face. With a drone, you're looking at 5 minutes. So it's a lot faster.
Lovely. Cheers. Thanks so much. There was a follow-up question. It is in French, though, from here. We have a translation. Thanks very much. Adele, translation, it was, what georeference 3D coordinate system is used for the images?
So it's whatever you like. We can use a mind grid, or you can use whichever region of the world you're in. Do you want me to answer that one in French as well, or just stick to the English translation for now?
Oh, if you can speak in French, I suppose that'd be fantastic for the person who's asking the question. But
I'll give it a go.
You could do both then. I think the larger audience would prefer the English version.
Yeah, so it's pretty much whatever your mind grid is set to. You can geo-reference to certain points on the ground. So you sort of lay out your points in a triangle fashion, if possible, one at the bottom of the face, one at the top, and just sort of triangle across the face that way. And then you'd get a surveyor to pick up those individual points. And then in the software, you'd actually assign those coordinates to those points in the images and georeference that way. And that could be to world grids, mind grid, whatever you like, whatever grid in there. It's not limited.
Thank you. Look, I really appreciate your presentation and the questions that you've answered. Thank you very much.